Now, in this lecture, we'll find out the area of the green shape using two different methods. In the drawing, we have a circle. Inside this circle, we have triangle ABC. We know that side AB of the triangle is equal to 14 units in its length, side BC equals to 14 units, side AC equals to 15 units. And our mission is to find out the area of this green shape. Okay, so we start with the first method. Actually, we have here rule number 4. According to rule number 4, the area of triangle ABC is equal to the square root of S times S minus A times S minus B times S minus C. So here we have triangle ABC, side AB of the triangle is equals to A units, side BC equals to B units, and side AC equals to C units. And S is the semi-perimeter of this triangle ABC. The semi-perimeter is the perimeter of the triangle over 2. The perimeter of this triangle is equals to the sum of its side lengths, that is to say it is A plus B plus C, and when we will divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of this triangle ABC equals to A plus B plus C over 2. AB is the length of side A is the length of side AB, B is the length of side BC, and C is the length of side AC of this triangle ABC. So the area of this triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. So actually we can implement this new rule number 4 in our drawing. Well, in our drawing we have this triangle ABC. So first of all, we find out the semi-perimeter of this triangle ABC. So the semi-perimeter of this triangle ABC, S, is equals to AB plus BC plus AC over 2. Okay, again, the semi-perimeter of this triangle ABC equals to the perimeter that is AB plus BC plus AC over 2. So we define side AB as A, and A equals to 13. We define side BC of this triangle ABC as B, and B equals to 14. And we define side AC of this triangle ABC as C, and C equals to 15. So S equals to AB, that is A, plus BC, that is B, plus AC, that is C, over 2. A is 13, plus B is 14, plus C is 15, over 2. So the semi-perimeter of this triangle ABC equals to 13 plus 14 is 27. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC equals to 21 units. And we have already found out that according to our definition, A equals to 13, B equals to 14, and C equals to 15. According to the new formula, the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. So the area of triangle ABC is equals to the square root of S. S is 21. Again, S is 21 and A is 13, so S minus A is 21 minus 13 times S minus B. S is 21 and B is 14, so S minus B is 21 minus 14 times S minus C. S is 21, C is 15, so S minus C in total it is 21 minus 15. So I finally found out that the area of triangle ABC, according to the new formula, and rule number 4, is equals to the square root of 21. 21 minus 13 is 8. 21 minus 15 is 7. Times 21 minus 15 is 6. Here we substitute 21 by 3 times 7. We substitute 8 by 2 times 2 times 2. And we substitute 6. Here we have 8. It is 2 times 2 times 2 times 7. And we substitute 6 by 2 times 3. So actually, we found out that the area of triangle ABC, in total, it is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2. We have 2 4 times, and again times the square root of 2 times 2. Repeat again. The area of triangle ABC according to rule number 4 equals to this expression. So the area of triangle ABC in total, according to rule number 4, equals to the square root of 3 times 3 is 3, times the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2, and we have 2 times 2 4 times, so times the square root of 2 times 2 is 2. So the area of triangle ABC equals to 3 times 7, that is 21, 21 times 2 is 42, and 42 times 2 is 84. So actually found out that the area of triangle ABC equals to 84 square units. Okay. And it is very clear from the drawing, we are looking for the area of this green shape. From the drawing it is very clear that the area of the green shape is equals to the area of the circle minus the area of triangle ABC. This circle blocks triangle ABC. And we have here rule number 6. That gives us the area that gives us the radius of any circle that blocks triangle ABC. Here, according to rule number 6, we have here this circle that blocks triangle ABC. So the radius of this circle that blocks triangle ABC, that is to say capital R, equals to A times B times C over 4 times the area of this triangle, triangle ABC. Again, here we have triangle ABC that is blocked by this circle. Side AB of this triangle equals to units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. So according to rule number 6, we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So the radius of this circle, we define the radius of this circle as capital R. Capital R must be equals to A times B times C over 4 times the area of this triangle, triangle ABC that is blocked by this circle. Repeat again, according to rule number 6, the radius of this circle that blocks triangle ABC is equals to A times B times C, that is the multiplication of the side lengths of triangle ABC that is blocked by the circle over 4 times the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. So the radius of this circle that blocks triangle ABC, capital R, equals to A that is 13 times B that is 14 times C that is 15 over 4 times the area of triangle ABC. The area of triangle ABC equals to 84 square units. Here we divide both the numerator and the denominator of this expression by 14. So in the numerator we have 14, so 14 over 14 is 1, so in the numerator we left only with 13 times 15 over 4 times 84 over 14 is 6. So in total the denominator we left with 4 times 6. In the next step, we divide both the numerator and the denominator of this expression by 3. And we get that in the numerator we have 13 times 15 over 3 is 5. So in the numerator, in total we have 13 times 5 over, in the denominator we have 4 times 6 over 3 is 2. So in total in the denominator we left with only 4 times 2. So 13 times 5 is 65, and 4 times 2 is 8. So actually found out that the radius of this circle that blocks triangle ABC, capital R, equals to 65 over 8 units. Okay, now it is very easy to find out the area of this circle. The area of any circle is pi times the radius squared. So actually the value of the green area it is equals to the area of the circle minus the area of triangle ABC. Repeat again. From the drawing it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Again, the area of the green shape or the green area equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and we have already found out that the area of triangle ABC equals to 84 square units. We have already found out that r equals to 65 over 8. Therefore, r square is 65 over 8 square minus 84. So, the area of the green shape in total will be equal to this expression in total, pi times 65 over 8 square equals to 207.394 square units minus 84. So the area of the green shape in total is equals to 207.394 minus 84. 207.394 minus 84 equals to 123.394 square units. And that is the answer to the question. Repeat again. The area of the green shape in total it is equals to 123.394 square units. Again, the area of this green shape equals to 123.394 square units. So we actually finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do a construction. That is to say, from point A, we will draw perpendicular on BC. So, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. we'll define the length of line segment AM as h, and we'll define the length of side BM as x. It is given as the question that side BC equals to 14 units. According to our definition, side BM equals to x, therefore the missing side MC must be equal to BC minus BM. That is to say, CM equals to BC, that is 14, minus BM, that is x. So in total, CM equals to 14 minus x. CM or MC equals to 14 minus x units in its length. In the next step, I will copy the right triangle ABC in a new page, and we will implement on this right triangle ABM the Pythagoras theorem. So actually, this is the right triangle A and B that I copied from the original drawing. AM equals to h according to our definition, BM equals to x according to our definition, and the length of side AB is equals to 13 units according to what is given as the question. By PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle A and B, we get that AB squared, this will be equation number 1, AB squared equals to BM squared plus AM squared. So AB is 13, therefore AB squared is 13 squared, that is 169, and it is equals to BM squared. BM is x, therefore BM squared is x squared plus AM squared. AM is 8, therefore AM squared is x squared. So actually found out that according to equation number 1, 169 equals to x squared plus x squared. Here we subtract x squared from this equation number 1, and we get according to equation number 1, x squared equals to 169 minus x squared. Okay. In the next step, I will copy the right triangle AMC in a new page, and we will implement on this right triangle AMC the Pythagoras theorem. By PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle AMC that I copied from the original drawing. The hypotenuse AC equals to 15 units according to what is given as the question. AM equals to 8 according to our definition. And we have already found out that side MC of this triangle AMC equals to 14 minus x. So according to the Pythagoras theorem, in this right triangle AMC, AC squared equals to AM squared plus MC squared. So AC is 15, therefore AC squared is 15 squared, that is 225. And it is equals to AM squared. AM is 8, therefore AM squared is 8 squared. Plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. So here we subtract 14 minus x squared from this equation. And we get that according to equation number 2, 8 squared equals to 225 minus 14 minus x squared. This is according to equation number 2. While according to equation number 1, we have already found out that 8 squared equals to 169 minus x squared. So we have two different expressions for 8 squared. So in the next step, we'll create equation number 3. So equation number 3 states that 8 squared according to equation number 1 must be equal to 8 squared according to equation number 2. So 8 squared according to equation number 1 is equals to 169 minus x squared. And it must be equal to 8 squared according to equation number 2. 8 squared according to equation number 2 is equals to 225 minus 14 minus x squared. So according to equation number 3, 169 minus x squared equals to 225 minus, we'll open the brackets here, 14 minus x squared equals to 14 squared, that is 196 plus x squared minus 2 times 14x is minus 28x. Again, minus 14 minus 2 times 14x is minus 28x. So in conclusion, found out that according to equation number 3, and 69 minus x squared equals to 225. Here we'll open the brackets. We get here minus 196 minus x squared. Minus and minus is plus, so it is plus 28x. So we found out that according to equation number 3, here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of equation number 3, we left only with 169, and it is equals to 225 minus 196 is 29, plus 28x. Here we'll subtract 29 from this equation, equation number 3, and we'll get that 169 minus 29 is 140. 140 equals to 28x. Here we divide this equation, equation number 3, by 28, and we get that x equals to 140 over 28 is 5. So x equals to 5. According to equation number 1, we found out that h squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared, but x equals to 5. Therefore, x squared must be equal to 5 squared, that is 25. So, we actually found out that according to equation number 1, h squared equals to 169 minus 25, that is 144. So, found out that according to equation number 1, h squared equals to 144. Here we take a root out of this equation, and finally we get that h equals to the square root of 144, that is 12. So h equals to 12 units, and x equals to 5. You can write here that h equals to 12 units, and x equals to 5. Okay. So, in the next step, we will define the center of this circle as O, and we will join points A and O together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We'll define the radius of this circle as capital R. In the next step, we will extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO and this circle as P. So here we created chord AP. This is chord AP. Chord AP passes through point O, that is the center of this circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord AP is the diameter of the circle. And we also know that the diameter of any circle is twice as long as the radius. We define the radius of this circle as capital R, therefore the diameter AP must be equal to R. So the length of chord AP is 2R. This is the diameter of this circle. In the next step, we'll join points C and P together by a straight line. By joining points C and P, we actually created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. So in the drawing we have peripheral angle ACB. This is peripheral angle ACB that rests on AB, and AB is the diameter of the circle. Therefore, peripheral angle ACB is equal to 90 degrees. So any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, peripheral angle ACP, according to rule number 7, must be equal to 90 degrees. So this is peripheral angle ACP, and it is equal to 90 degrees according to rule number 7. Okay. Here we can implement also rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have peripheral angle ADB that rests on chord AB, and it is equal to theta. And we also have peripheral angle ACB that rests on the same chord AB. And because of the fact that those two peripheral angles rest on the same chord, therefore they must be equal to each other. So if peripheral angle ADB equals to theta, then peripheral angle ACB must be also equal to theta. Again, those two peripheral angles rest on the same chord AB, therefore they are equal to each other. That is to say, peripheral angle ADB equals to peripheral angle ACB. So if this angle equals to theta, then the other angle must be also equal to theta. So actually we can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC. But we also have peripheral angle ABC that rests on the same chord AC. That is to say, those two peripheral angles that rest on the same chord AC must be equal to each other. So if we define peripheral angle, the size of peripheral angle APC as theta, then the size of this peripheral angle ABC that rests on the same chord AC must be also equal to theta. I repeat again, those two peripheral angles rest on the same chord AC, therefore they must be equal to each other. So if this peripheral angle equals to theta, then this peripheral angle ABC must be also equal to theta according to rule number 8. So in the next step we will focus on the right triangle APC. in this right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle, triangle A and B. In this right triangle, triangle A and B, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we will prove that the right triangle, triangle A and B, is similar to the right triangle, triangle APC. So I write it down. We prove that the right triangle, triangle ABM, is similar to the right triangle, triangle APC. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So I write it down. Angle ABM in triangle ABM is equals to this angle, angle APC in triangle APC. Angle ABM, triangle ABM equals to angle APC in triangle APC. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle A and B in triangle ABM equals to angle ACP in triangle APC. Repeat again. Angle A and B in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB. And it is equals to this angle, it is actually angle PAC. Repeat again. Angle MAB in triangle ABM equals to angle PAC in triangle PCA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in triangle ABM are correspondingly equal or congruent to all the three angles in the right triangle, triangle APC. Therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually proved that the right triangle, triangle ABM is similar, this is the sign of similar, to the right triangle, triangle APC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AEM in triangle ABM over AC in triangle APC is equals to AB in triangle ABM over AP in triangle APC. Repeat again, from the fact that those two right triangles are similar to each other, we will derive that AM over AC equals to AB over AP. AM equals to 12 units over AC. AC equals to 15 units. And it is equals to AB. AB equals to 13 units over AP. AP is the diameter of this circle, that is equals to 2R. So in conclusion, we found out that 12 over 15 equals to 13 over 2R. Here we'll cross multiply this equation and we'll get that 12 times 2R is equals to 13 times 15. So here we'll divide this equation by 12 and we'll get that 2R equals to 13 times 15 over 12. We divide this equation by 2 and we get finally that R, that is the radius of the circle, equals to 13 times 15 over 2 times 12. We will divide both the numerator and the denominator of this expression by 3. And we get that R equals to 13 times 15 over 3 is 5. So in total, in the numerator we have 13 times 3 over, in the denominator we have 2 times, and 12 over 3 is 4. So in total, in the denominator we have 2 times 4. So actually found out that the radius of the circle R equals to 13 times 5, that is 65, over 2 times 4, that is 8. So the radius of this circle R equals to 65 over 8 units. So the area of the green shape from the drawing, it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. So the area of the green shape in total is equals to the area of the circle. The area of any circle is pi r square. Minus the area of triangle ABC. We already found out that the area of triangle ABC, actually the area of triangle ABC the area of any triangle equals to the base of the triangle that is BC times the height to the base that is H over 2. Repeat again. The area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is H over 2. So, the area of the circle is pi r squared. And we have already found out that r equals to 65 over 8, therefore r squared is 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12, over 2. This expression in total, it is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC in total is equals to 84 square units. So finally we found out that the area of the green shape equals to 207.39 square units minus 84. So it is equals to 123.394 square units. And that is the answer to the question. The area of this green shape, according to the second method also, it is equals to 123.394 square units. So in the next step, I will summarize the lecture. We'll start with the first method, of course. So, in the drawing we have a circle. Inside this circle we have triangle ABC. We know that the length of side AB is 13 units, side BC equals to 14 units in itself, and side AC equals to 15 units. Our mission is to find out the area of this green shape. So, in the first method, I presented to you a new rule that is actually rule number 4. Rule number 4 helps us to find out the area of any triangle. So here we have triangle ABC that could be any triangle. The length of side AB is A units, side BC equals to B units in itself, and side AC equals to C units in itself. So the area of this triangle, triangle ABC, that could be any triangle, equals to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of this triangle. The semi-perimeter of any triangle is equals to the perimeter over 2. And the perimeter of any triangle, it is the sum of its side lengths. And when we divide the perimeter by 2, we get the semi-perimeter. Therefore, the semi-perimeter of this triangle, triangle ABC, must be equal to A plus B plus C, that is the perimeter, over 2. So S equals to A plus B plus C over 2. A is the length of side AB, B is the length of side BC, and C is the length of side AC. So actually, can implement the new formula in our drawing. We actually define the length of side AB as A, and A is 13. We define the length of side BC as B, and B is 14. And we define the side AC of this triangle ABC as C, and C is 15 according to what is given us in the question. In the next step, we found out the semi-perimeter of this triangle ABC. According to the new formula, the semi-perimeter must be equal to the perimeter, that is the sum of its side lengths, that is to say it is A plus B plus C over 2. A is 13, B is 14, and C is 15. 13 times 14 is 27, and 27 plus 15 is 42. 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC is equal to 21 units. Again, according to our definition, A equals to 13, B equals to 14, and C equals to 15. The only thing that is left to do here is to put the data inside the formula for the area of any triangle. And so we did it. This is the formula according to rule number 4 for the area of any triangle. So according to this formula, the area of our triangle ABC equals to the square root of S. S is 21 and A is 13. So S minus A is 21 minus 13. B is 14, so S minus B is 21 minus 14 times S minus C. C is 15, therefore S minus C is 21 minus 15. So here 21 minus 14 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. Then we substitute 21 by 3 times 7. We substitute 8 by 2 times 2 times 2. Here we have 7. And we substitute 6 by 2 times 3. So in total we found out that the area of this triangle ABC, according to the new formula, is equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. And the square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2. Again, the square root of 2 times 2. We have 4 times 2 in this equation, so it is, we have again 2 times 2, that is 2. So actually we found out that the area of triangle ABC in total, it is equal to 3 times 7, that is 21, 21 times 2 is 42, and 42 times 2 is 84. So in total the area of this triangle ABC equals to 84 square units. Then I presented to you rule number 6. Rule number 6 talks about the radius of any circle that blocks triangle ABC, that could be any triangle. So we have this circle that blocks triangle ABC. Then for side AB is a unit, side BC equals to B units in itself, and side AC equals to C units in itself. The radius of this circle is R, or capital R. According to the new formula, the radius of this circle, capital R, that blocks this triangle ABC, will be equals to A times B times C, that is the multiplication of the side lengths of this triangle by each other, over 4 times the area of this triangle ABC. So actually we can implement rule number 6 in our drawing. According to rule number 6, the radius of this circle that blocks triangle ABC must be equal to A times B times C, that is the multiplication of the side lengths of triangle ABC by each other, over 4 times the area of triangle ABC. And we already found out that the area of triangle ABC is equal to 84 square units. A is 13, B is 14, and C is 15, over 4 times the area of triangle ABC, that is 84. Here we divided both the numerator and the denominator of this expression by 14. So in the numerator we have 14 over 14 is 1, so in total in the numerator we left only with 13 times 15. In the denominator we have 4 times 84 over 4 is 6. So in total in the denominator we have 4 times 6. Then we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total in the numerator we have 13 times 5 over, in the denominator we have 4 times 6 over 3 is 2. So in total in the denominator we have 4 times 2. So capital R equals to 13 times 5, that is 65, over 4 times 8, over 4 times 2, that is 8. So in total we found out that the radius of this circle that blocks this triangle ABC equals to 65 over 8 units. Okay, what is the area of this green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again. From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r square, minus we already found out that the area of triangle ABC equals to 84 square units. R is 65 over 8, therefore r square is 65 over 8 square. So in total, the area of the circle equals to pi times 65 over 8 square, minus the area of the triangle ABC, that is 84 square units. So this expression in total is equals to 207.394 square units, minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 equals to 123.394 square units. Therefore, we actually found out that the area of this green shape equals to 123.39 square units. We finished with the first method. In the next step, I presented to you how to find out the area of this green shape according to the second method. In the second method, we did a construction from point A, we draw perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We define line segment AM as H, and we define line segment BM as X. So BM equals to X and BC equals to 14. Therefore, the missing side MC must be equals to BC minus BM. BC is 14, BM is X, so in total MC equals to 14 minus X. Then I copied the right triangle ABM in a new page and we implemented the Pythagoras theorem in this right triangle ABM or AMB. This is the right triangle AMB that I copied from the original drawing. AB equals to 13 units according to what is given as the question. AM equals to H according to our definition, and BM equals to X also according to our definition. So in this triangle ABC by PT is the equation for Pythagoras theorem. AB square equals to AM. AB square equals to BM square plus AM square. So AB is 13, therefore AB square is 13 square, that is 169. And it is equals to BM square. BM is X, therefore BM square is X square plus AM square. AM is H, therefore AM square is H square. So in total we found out that 169 equals to X square plus H square. We subtracted X square from this equation and finally found out that according to this equation number 1, H square equals to 169 minus X square. Then I copied the right triangle AMC in the new page and implemented the Pythagoras theorem on this right triangle AMC. This is the right triangle AMC that I copied from the original drawing. By PT is the relation for Pythagoras theorem. AM equals to H according to our definition. AC equals to 15 according to what is given as the question. And we have already found out that MC equals to 14 minus 6. So according to the Pythagoras theorem, in this right triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225, and it is equals to AM squared. AM is h, therefore AM squared is h squared, plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. Here we subtracted 14 minus x squared from this equation, and found out finally that according to this equation, equation number 2, x squared equals to 225 minus 14 minus x squared. This is according to equation number 2, but according to equation number 1, we already found out that h squared equals to 169 minus x squared. So we have two different expressions for h squared. Therefore, we created equation number 3. Equation number 3 states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 is 169 minus x squared, and it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So according to this equation, equation number 3, 169 minus x squared equals to 225. We open the brackets here. 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x is minus 28x. So according to, we found out that according to equation number 3, 169 minus x squared equals to 225. We open the brackets here. So after we open the brackets, we will have here minus 196 minus x squared, minus and minus is plus 28x. So here we have x squared on both sides of the equation, so x squared will get cancelled. So in this side of the equation, we have to leave 169. That is equals to 225 minus 196 is 29 plus 28x. So in total, we found out that according to equation number 3, 169 equals to 29 plus 28x. We subtracted 29 from this equation, and finally we found out that 140 equals to, actually 169 minus 29 is 140. So 140 equals to 28x. We divided this equation number 3 by 28, and finally found out that x equals to 140 over 28 is 5. So x equals to 5 units. Then we have equation number 1. According to equation number 1, h squared equals to 169 minus x squared. So it is 169 minus x squared, but x equals to 5. Therefore, we can substitute x by 5. If x is 5, then x squared is 5 squared, that is 25. So in total, we found out that according to equation number 1, h squared equals to 169 minus 25, that is 144. So h squared equals to 144. We took a root out of this equation and finally found out that h equals to the square root of 144, that is 12. So here we can write down that h equals to 12 units. Then we defined the center of this circle as O. We join points A and O together by straight line. Point O is the center of the circle, point A is the point on the circle itself. Therefore, AO is the radius of this circle that we defined as capital R. Then we extended the radius AO by a straight line until it touches the circle at point P. In this way, we created chord AP. Chord AP passes through the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius. The radius of the circle is R, therefore the diameter AP must be equal to 2R. Then we join points P and C together by straight line. By joining points P and C, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we know according to rule number 7 that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Repeat again on rule number 6. According to rule number 7 actually, if a peripheral angle rests on the diameter of the circle, it must be equal to 90 degrees. Here we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. So we implemented rule number 7 in our drawing. In our drawing, we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, this peripheral angle ACP equals to 90 degrees, according to rule number 7. Then we implemented also rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have peripheral angle ADB that rests on chord AB, and we also have peripheral angle ACB that rests on the same chord called AB, therefore they are equal to each other. So if peripheral angle ADB equals to theta, then peripheral angle ACB must be also equal to theta. We can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, and we have also peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles rest on the same chord called AC, therefore they must be equal to each other according to rule number 8. So if this peripheral angle APC equals to theta, then the other peripheral angle ABC that rests on the same chord called AC must be also equal to theta. So both those two peripheral angles, they are both equal to theta, therefore they are equal to each other according to rule number 8, because they rest on the same chord called AC. So in the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we prove that the right triangle ABM is similar to the right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually succeeded to prove that all the three angles in the right triangle ABM are correspondingly equal to all the three angles in triangle APC. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AM in triangle ABM over AC in triangle ACP equals to AB in triangle ABM over AP in triangle ACP. I repeat again, we derive that AM over AC equals to AB over AP. AM is 12, AC is 15, AB is 13, and AP is 2R, that is the diameter of the circle. Here we cross multiply this equation and found out that 12 times 2R equals to 13 times 15. We divided this equation by 12 and found out that 2R equals to 13 times 15 over 12. We divided this equation by 2 and finally found out that R equals to 13 times 15 over 2 times 12. We divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total in the numerator we have 13 times 5 over, in the denominator we have 2 times 12 over 3 is 4. So in total in the denominator we have 2 times 4. So R equals to 13 times 5 over 2 times 4. 13 times 5 is 65, and 2 times 8 is 2 times 4 is 8. So the radius of this circle R equals to, in total, to 65 over 8. What is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. Okay, so the area of the green shape equals to the area of the circle, that is pi r square, minus the area of triangle ABC. The area of any triangle equals to the base of the triangle times the height to the base over 2. the base is BC, the height is H over 2. Okay, again, the area of triangle ABC equals to the base that is BC times the height that is H over 2. The area of the circle equals to pi r squared. R equals to 65 over 8, therefore r squared is 65 over 8 squares. BC is 14, H is 12 over 2. In total, this expression equals to 207.394 square units, minus 14 over 2 is 7, and 7 times 12 is 84. So in total, the area of triangle ABC equals to 84 square units. So the area of the green shape in total, it is equals to 207.394 minus 84 square units. So 207.394 minus 84 is equals to 123.394 square units. In conclusion, we found out that the area of the green shape, according to the second method, also it is equals to 123.394 square units. Okay, thank you very much.